In this video, we're going to have a look at how to solve problems involving simultaneous equations. This regularly comes up in National 5 and it has important links to higher maths as well. Got two examples to work through. Usually, a question will look something like this here. Solve algebraically the system of equations. And you can see we've got two equations. 5x plus 2y is 14. 4x minus 5y is minus 2. Hopefully you can see that in both equations there are two things that we do not know. We need to work out what is x and what is y. There's different ways that you can go about doing this. What we want to do though is we're going to use the process of elimination. What that means is we're going to choose one of our variables, either x or y, and choose to eliminate them by doing some scaling. So in this problem I'm going to choose to eliminate y. So I'm going to look at the numbers in front of the y's here. I've got a 2 and a negative 5. Those numbers are not the same. In order to be able to eliminate, we need the numbers to be the same. So what we can do is we can scale each equation up to make sure we get the same number. So I'm going to label this first one equation 1. I'm going to label this equation 2. I'm going to multiply this equation by 5. Because if I do that, I'm going to get a 10y here. I'm going to multiply this equation by 2, because then I'm going to get a minus 10y here. And when those numbers are matching up, we can then start to eliminate. So I'm going to multiply everything in equation 1 by 5. That's going to be 25x plus 10y is equal to 70. 8x minus 10y is equal to negative 6. And I'm just going to relabel these equation 3 and equation 4. So I have scaled here. I didn't need to choose the y's to eliminate. I could have chosen the x's. For example, I could have scaled these in such a way that both numbers would be 20 in front of the x, and we could have worked at it from there, but I've chosen to go with the y's. Okay, so we now want to try and eliminate the y's. So we've got a few options, or we've got two options. We can add these equations together, or we can subtract them. See if we subtracted them. Do not write this down. If we subtracted them, we would get 10y minus 10y, which would give us 20y. So we're not going to subtract them in this case, we are going to add. If we have a look in this particular case, the signs of the y's are different. When the signs are different, you're going to be adding. So I'm going to add 25x and 8x, that's 33x. 70 plus minus 6 is, well, that should be minus 4, apologies. 2 times minus 2 is minus 4. So 70 plus minus 4 is 66, and we can divide throughout by 33, and we'll get x equals 2. But remember, the goal of the equation, or the goal of the question, was to work out what is x and what is y. We've worked out what x is, we need to now work out what y is. So what we're going to do is we're going to take our answer and we're going to substitute it into equation 1. So equation 1 was 5x. So 5 lots of x. So x is 2, so it's 5 lots of 2. Plus 2y is 14. So we're going to have 10 plus 2y is equal to 14. Subtract 10 from both sides. 2y is 4. Divide both sides by 2. We're going to get y equals 2. So our solution is x equals 2 and y equals 2. Okay, example 2. Solve algebraically the system of equations. So this is equation 1, this is equation 2. One wee thing to watch out for here. Notice that the order here goes x, y, number. Whereas in this one here, it goes yx number. So before we do anything, let's rearrange them to be the exact same. So I want x's to be first. So 2x plus 3y is minus 10. And then 5x plus 2y is equal to minus 14. That's equation 1 and equation 2. It's easier when everything's aligned. So I can choose what I want to do here. I can choose to eliminate the x's, or I can choose to eliminate the y's. If I choose to eliminate the x's, it makes sense that the number I'm aiming for here is 10. I could choose to do that. I'm going to choose to do the y's, however. I'm going to choose the y's because I think 3 and 2, well, the lowest common multiple of 3 and 2 is 6. So I can manipulate both these equations in order to get a 6 there. I'm going to need to times equation 1 by 2 and equation 2 by 3 in order to get that. So that's going to be 4x plus 6y is minus 20. 15x plus 6y is equal to minus 42. Okay, I'll call this equation 3 and I'll call this equation 4. This time, if we're eliminating the y's, we look at the signs and they're the same. When the signs are the same, we're going to subtract. We're going to do 3 subtract 4. 4x subtract 15x is minus 11x. And then this part here, I'm just going to do it the side, minus 20 minus minus 42. That's going to become minus 20 plus 42, which is 22. Divide both sides by negative 11. I'm going to get x equals negative 2. But remember, we want two answers. I've got one. So I need to take this answer. I'm going to substitute it into equation 1. What is that going to be? So it's 2x, so it's 2 lots of minus 2, plus 3y is minus 10. That's going to be minus 4 plus 3y is minus 10. I'll add 4 to both sides. Minus 6. I'll divide both sides by 3. And I'm going to get minus 2. So our solution here is going to be x equals minus 2. And y equals minus 2. Okay, so your strategy is you want to try and get the same number in front of one of the letters. To do that, you're going to need to scale each equation in order to achieve that. Choose to either add or subtract, solve to work out the unknown, and then substitute that value into your original equation. Hopefully that was helpful. Thank you very much.